Okay, let us start our third class. In the last class we talked about sets being equal, sets being subset, and then a proper subset, superset, a proper superset. We have also talked about an element, like one, or like an element 1, let's say, belongs to A, if A is something like this. So now what we're going to do is, and we have talked about sets in terms of rooms and stuff, something like that. Now we are going to talk about a situation where there is a room and there's nothing in the room, which is a bit different from there is a room and there is a man having no grapes. The difference is there is no man holding a grape, but here there is somebody holding 0 grapes. That is, this room is empty. This room has a man holding 0 grapes. The point I'm trying to make is that the situation of having 0 grapes has a position in this room. You can have 0 grapes and you're still in the room. That is, situation of having 0 grapes has a position. So what I want you to understand, when I write 0 inside a set, yes, there's literally no grapes in the room, but we are allowing a position, a small area in the room where you can have no grapes. So you have a position for a man who can have 0 grapes. And if I write 1, then I have a position for another man, okay? And we're creating space for a person here. And yes, they have 0 grapes. If I write 1, you have space for another person and they have 1 grape. If I write comma 2, then there is another space being created in this room and there is a man with 2 grapes. Now you see in this room, what you have to understand is, there is no space. The room doesn't have space for a man. You can't stand. Problem is, you cannot stand in this room. You cannot stand in this room. It's not just about the room being empty. Of course, if you look at here, if you think everything in terms of grapes, this room also has 0 grapes. Even this room has, if I just take the room of a man with 0 grapes equal to 0, even this room has 0 grapes, and this room also has 0 grapes. But what is the difference? You have a position. There is a position where you can stand and have 0 grapes in your hand. So you can have the number 0. In that room, you have place to stand. 0 has a place to stand over there. But in this room, you cannot stand in that room. So it doesn't matter if you're outside this room and you have like some 100 grapes with you, you can't stand. Even if you I have a door, I'm gonna open the door, go inside, you can't stand. That's the room. There's no place to stand. Then you might ask me, if there is no place to stand, how do you build a room? Well, I don't actually know how in real life we can build rooms without having a floor. Or probably think about something like this. No, the floor is hollow. So you can't actually stand. It's just a hollow. If you stand here, you probably just fall through. And this is the room. Yeah. You can't exist in the room. And the room is just this. Like only this volume is considered the room. So even if you fall down, if you just fall down into this area, if you fall down into this area over here, that's not the room. Only this is the room. This is not the room. And let's say this room has a floor, like the one below. Let's just say that, let's say this has a floor. Okay, that's not visible. Let's say this has a floor. Floor exists. But this room over here, okay, this floor, this is hollow. It's the no floor. So you can't obviously, even if you have a door, you walk through, you can't stand. That's the empty set. You can't stand on the floor. It's not possible. There's nothing in the room because the moment you enter the room, you can't stand there. It doesn't make sense, really. There's nothing in that room. It's a bit different from having no grapes. It's just nothing's there. Like, I get it if you have a set with 0. And people would say, hey, you at least have the element 0. But hey, what does it mean to have 0? It means to have nothing. But it's a bit different. So a room with actually a man holding 0 grapes actually has a floor, and there's a guy holding 0 grapes. Like, no grapes at all. It's not a grape. This circle, I meant 0. Like, 0 grapes. That's what I'm trying to say. Which is obviously different from this room, which doesn't have a floor. You know what I'm saying? So, what is the difference between an empty set and a set with the element 0 in it? Is this actually has a place where you can keep that 0, a floor where you can keep the 0. It's small though. It doesn't have 2 elements like this. This has 0 and 1. So this has, like, imagine a room with 2 people. This has a position for 2 numbers, but this only has, like, a position for not having anything. So you're allowed to not have anything here. I have a floor, and you can stand there and still not have anything. Here I have like a floor for 2 positions, and you in one position, yeah, you don't have anything. Okay, then be here. Okay, if you have something, fine, you're here. But in this, you can't stand. It's not possible. Like, it doesn't matter if you have, like, a lot of grapes or you don't have grapes. It doesn't just matter. You can't stand. Like, you gotta move on with the fact that you cannot stand and, still live somehow. You can't. The point is, you cannot be here. It's not possible. It doesn't have a floor. Like, you cannot put any number inside the empty set. This is actually called the empty set. Okay? Because you cannot put 1. If you put 1, just imagine there's a room. If you put a person with a grape, it just falls down. Where does it fall down into? Well, ideally, it just falls down into a room with a person with 1 grape in it. So if you put something inside, it's no longer the empty set. It's actually the set with 1 person in it. You cannot put a number in this and ask this room to be the same thing. It's not. No set is like that. You cannot. So, we'll talk about a scenario. Let us say, at this point in time, let us just say you have 2 people with, 1 grapes. That's like 1, 1. But the rule that we invented before is that a room can only have person of 1 kind. Like, you cannot have clones in the room. Makes 1, 1 also equal to the set 1, because we don't allow clones to exist. What I'm trying to tell you, if you put 1 more person in this room here like this, it's also gonna be the same. It's the same thing. Like, sure, you still don't allow them to exist, and you kind of cut them off, and you're like, nah, bro, it's just, you don't allow that, so it's just 1 person. I'm trying to explain something to you that even if you have like multiple clones in a room, because you kind of don't allow that to happen, all that cuts down into becoming is just okay. So instead of saying equal to, I would rather say something else because I don't think equality is like a nice thing to say here. It's more like we push them down to this, like you don't allow this kind of a thing. You know, it's like, no, we don't want clones. You don't allow clones. That's not how this works. Sets don't allow clones. So even if you're going to add people, we're just going to be like, no, 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 no. And we're going to give you back the set or a room without any clones or anything in there. And what I want to tell you over here is the empty room, you know, it doesn't have a floor. The empty set doesn't have a floor. So this is not, so if you look at this, sorry, this is, yeah, empty set. I just put a 1 there. I was talking about some other set. I'm coming back. This, oh, what's happening? This is the empty set without a floor. So I want you to imagine that because you're going to have problems with empty sets and people would be talking about bringing an object from the empty set. They would talk about, hey, call a guy from that room, you know, the empty room. And you need to think about it. If you want to bring someone from the empty room, there's nobody in the empty room, okay? There's nobody there. You can't. There's nobody there because you cannot stand. You don't have a position to stand on, so you can't be there. It's like floor is magma kind of a thing. It's not even magma, it's just not there. It's hollow. You'll drop down. So nothing comes from the empty room. That's what I want you to know. So you will have questions where, okay, all the people from the empty room and all the people from room A, please come into room B. That's what you're going to have. And then you need to understand, no one's really coming from the empty room. Like, you have to understand that. Okay. So now we're going to be talking about, so now you understood the empty set. I'm going to tell you what it's called. It's basically written like this. It's called phi. It's, yes, literally like this, written this way. It's called the empty set. Okay, so that's one understanding of the day. Let's go to the next part. So now let's talk about calling people from different rooms and like, you know, like you have a big party. Okay, you have like a big party. So you're going to call people from room A, B, and C and put them like in room D, okay? So let us say room, at this point in time I'll write sets. So when I write a set and I put a number, I want you to imagine people holding a grape and something. Because the reason I say a person holding a grape, the reason I have that person there is because the person creates a position for the grape. Like the grape is in that person's hand, you know, like in their hand, in that room. This grape has a position. This guy or girl is holding that grape. And that's the only reason the grape can exist in that room. Because the room has created a position, a place where the grape can be held and the grape can exist there because of the position provided. That I want you to know that. So when I write one has a position in that set. One has a place where it can stand on its 2 feet and it can live there forever in that room. So it's actually there, and you need to understand that. So that's why I have people holding grapes as an analogy, because I want you to know there is a person, like holding a grape is the same as there is a position for one to be in the room, in which the room is essentially the set. We're gonna go. See, if you're gonna talk about other things like a class or a field or a family, the whole concept of a room might not realistically make sense. But we're gonna go. We're gonna, especially for a class, it doesn't in a way make sense. Also in a way for a field. But it's fine. We're gonna understand it. Essentially, you can make sense of things once you have a proper understanding of sets. Okay, so where are we at? We're in 1. So right now I'm not going to draw people holding grapes. I will just write the numbers in a set. And then we'll talk about, the party right now. So I want you to imagine people holding grapes for a while. Or you can imagine 1 sitting in a place, 2 sitting in a place, and 3 sitting in a place. Okay? And the reason I still say people is, see, if there's a guy holding 1 grape and there's a person holding 2 grapes. Now, does it really matter if that guy is on the left or like the right? Like, let's say that guy holding a grape is on the right this time. This is left, that's right. This is right, left. So, and now let's say this guy's over here. It doesn't really change the fact that it's the same though. It's like, is the picture same? No, the picture is not the same. But in reality, in life, like 2 people are in a room. 2 people are in a room no matter where they're sitting. The fact that 2 people are existing in the room doesn't really change because of where they're sitting. Probably if you take a photo, the photo will look different. That is, inside the room dynamics might be changing inside the room, but as far as you're considering outside, as far as you're outside the room, it doesn't really matter. All you need to know is there are 2 people in the room, and whenever you want, they're going to come out, or rather, they're going to give you a clone of themselves. So if you're going to call someone saying, Kiran, come out. Kiran, what are you doing? We need you at work today. So Kiran is going to come out. So Kiran is actually going to come out of that room, or rather send a clone of himself with 3 grapes. So 3 is going to, if you have a 2, 3. So 3, you need 3 doing something somewhere. So 3 is going to come out. Rather, it's going to send a clone of itself, that is 3. And it's going to do whatever you want to do. Oh, you want to add 3 to something. You want to multiply 3. You want to whole power 3. Wherever you need 3, whyever you need 3, for whatever reasons you need, it's going to come. A clone of 3 is going to come at whenever you need it. So as long as you're outside the set, and I need you to know you're actually outside of the set. You're not inside the set. You're not an element of the set. You're not a guy holding a grape. You're not standing in the room. Even if you have no grapes, if you're just standing in the room with no grapes, that room is going to look different. That room is going to look like 1, 2, 0. Okay? So in this, what I'm trying to say is that if you're inside, if you're really inside, if you're 0, then maybe it matters whether, you write it this way or you write that this way. It matters if you're 0, but you're not 0, okay? You're not really 0. Who you are is literally a guy outside. Like me, I'm outside the set, I'm outside the room. So you're not this person. So it doesn't matter. It actually does not matter. And you're not even taking photographs anyway. The only time the order matters is when you're taking photographs. You're not doing that. You're just dealing with the fact that you have 2 people holding different number of grapes. So that means to say, essentially, for our understanding or our business that we have with the rooms, 1, 2 is the same as 2, 1. For now, that's it. We're not really doing anything more than that. So yeah. So that's one thing I want you to know. The order inside doesn't really matter. The order inside doesn't really matter for sets. So, of course, you can have a set where the order matters, and that's going to be an ordered set. Like, okay, order matters. You gotta tell people if the order matters. If order matters, you gotta tell people. If you don't tell them, they're not gonna know. Because it doesn't make sense. Normally, how people are in a room doesn't really matter. But if it seriously matters, you gotta tell people it matters. That is to say, If it matters how the numbers are positioned in a set, you gotta tell or write it on paper that, hey, order matters. So please don't write 1 comma 2 is 2 comma 1 this time. This time it matters, everybody. You gotta tell that. Right now I'm telling you it doesn't matter. So unless someone tells you that it matters, it usually doesn't matter. Like, go by common sense. How you are, where you're standing in a party doesn't matter. Fact that you attended a party actually matters more than where you're standing. Does it really matter if you're having food like in the last corner of the cafeteria or in the middle or in the front? You're having food. That's all that matters. You're out there living. You're living in the colony. How does it matter if you're the first house or the second house? You have a house, you're living. All these numbers have a house. In the set, we're giving them a position, they're living. Let them live. It doesn't really matter if 2 is on the right side of 1 or 1's on the right side of 2 right now. Right now, it doesn't matter. Eventually, yes, it's gonna matter, but right now, it doesn't matter. Because 2 has nothing to do with 1. 2 has nothing to do with 1 right now. This guy is existing. Wait, I lost a grape. Yeah. This guy is existing independent of this guy. This guy's life has nothing to do with this fellow. So how does it matter where they are? Left or right, same thing. If this guy's existence depends on this guy, if the existence of 2 depends on 1, and the existence of 1 depends on 2, then I guess it matters where they are, Like, if it really matters, then, bro, you gotta probably be on the left or the right, in the front or the back, I don't know, something. But if it doesn't matter, it doesn't matter. And there are situations where the existence of a particular number depends on the existence of another number. Then it really matters where they are. You cannot just put them on the left or the right or the front or the back, because where they are matters. Because your whole life depends on, sometimes the whole life of little 2, like, just think about it, the little number, little 2, I call it. The whole life of little 2, this poor little guy, it depends on 1 sometimes. Sometimes it does. And you have to give that importance. So that importance we're going to give in functions, because numbers, their lives depend on each other. And we would be calculating that dependence. And that dependence is basically a function. In a way, the same thing for relations, but we'll come to it. So relations, functions, yes. Not the same thing, in a way, same thing, not same thing. I'll talk about it in the next couple of classes. We'll finish sets, we'll talk about how numbers can depend on each other and how that looks like. I'm not saying this in such dramatic sense, if you think about it, that it's dramatic. I'm not saying it in a cinematic or whatever way, just so that you understand. No, I'm not saying it like that. I want you to see they're actually alive, living in those spaces. The reason I'm saying all this is everything you do in mathematics is going to show up in real life. When you do physics, there will be particular particles or objects living in a particular place. And you have to take that very seriously. Okay, take something like this, right? Take an electron. Okay, if you know the spin of an electron. Okay, I'll tell you why I only allow a guy with 1 grape. Okay, I'll tell you. Take an electron. In an orbital for an electron. If you don't know orbital, fine. There is a circumstance where the electron has a spin of plus half and a spin of minus half. And electrons with the same spin, plus half, cannot be put beside each other. Yes, only a guy with... So there is a situation where there is a box, a small little space, okay? Not really box, but an area, a volume, where you have an electron, a literal particle, sometimes a wave, but a particle, which has a spin of plus half. And you cannot really put another electron with plus half spin in the same box. That's the same as saying you can't have clones together. Yes, so the point I'm saying is everything we do has some physical significance. That's why we're doing this stuff. It's a crazy idea to say, oh, clones cannot exist, but you're going to make clones. But it happens in real life. It actually does. You can't have plus half in a box. You can only have plus half and minus half in a box. And this happens in every atom, in every orbital, And it's like real life, right? Where atoms make up everything we see, and it's like real life, and we're dealing with it where 1 comma 1 is cannot exist. We're not allowing clones to be put in a box, but at the same time, you might have one. I have a set with 1. I have a set with 1 comma 2. But yeah, you have an electron here. You have electron of plus half spin somewhere else. Also, 1 can exist. The clone of this 1 exists in many places. But 1 comma 1 in a box, no. So this is not a joke. It's actually alive. It's existing. Like literally, if you're doing like a physics degree or something, you'll be like, damn, these things are alive. These things are out there. And yes, you've been doing that kind of stuff since you were a kid. Like if you're doing set theory, you should be able to understand, or at least not be surprised with electron behavior, because the same thing you're doing with 1, you tell 1 comma 1 cannot be in a box, but 1 can be there, and clones of 1 can be in other boxes. So you're doing this since you're a kid. It's real. That's why I'm telling you, we have a place. It is existing. There's a house for all these numbers. You have to take it that dramatically. Every time you do mathematics, it's real life. So take it that way. Where were we? Yes, order matters. So if order matters, you have to tell people order matters. And I was trying to say something and I forgot what I was saying. Where was I? Little 2, yes, I was talking about if the life of little 2 depends on 1, then where 2 is with respect to 1 matters. Now, we're going to move over that. We're going to come back to the party. We have a party to attend. So, I'll write that again. We have a party. Okay. A, B, C. Now, I'm just going to write sets. You imagine what you have to. 1. B is 1,2. C is 3. Now, I want to have a room with all these people in it. So, D. So, I'm going to have 1, 1,2. I'm going to call these guys. But, see, you have to understand one thing. When I'm calling these guys, that does not mean that this 1 is going to jump into. So, you got to imagine that's one very big thing. If there's a guy holding a grape, and I'm calling that guy into room number D, okay, which was initially there. So you have to understand, this room was empty, but this room has place. It's not like phi. It has a floor, and the floor has space. So it's not like phi. D is not phi. I want you to know that floor is being made for every person who comes in. So there's a new person coming in, we'll have one more floor space opening up for them. That's how room D is, okay? And if no one's coming in, we'll close it with a wall. So we have floor. We're not, though we're empty in the beginning, though there's nothing there, we can make floor for you guys who come from room A, B, C. We're not like phi. Our floor is not lava or it's not hollow. So when I say that I'm calling people, okay, I don't want you to think that this guy goes there and this room becomes empty without anything. It's like it has a floor, it can take someone, but this guy went out, now what to do? I have a position to have a guy here, I have enough space to hold a guy, but my guy went somewhere else. No, that's not what happens. This guy makes a clone of himself and that clone goes there. So what I'm trying to say is 1 still stays here, okay? 1 does not go anywhere. A still has 1 and this room is still alive. This room is still going to be there. 1 is still there. A clone of 1 is going to go here. A clone of 1 and 2 is going to go. A clone of 3 is going to go. So every guy is going to make a clone and send those clones up there. That's what's happening. Okay? That's what's going on. And of course, you can also have a question. I myself have a question right now. Okay, then how does this person travel? In what space does this 1 randomly travel? Right now, I'm thinking that it just disappears and appears right now. Because when I say there's a clone of 1 and it's gonna come here, is there a particular road on which this travels? And is there mathematical significance for that road? Or does it just pop up here and then, does the clone of 1 just pop up here? I myself don't really have an answer for it. So I am thinking, because I'll read a little more how numbers go from one set to the other. I'll read about it. But right now I'm thinking it clones itself and the clone pops up here. That's how I'm thinking. Now this one, as we know clones are not allowed, is just 1, 2, and 3. That's basically the party, and the party is basically called a union. So it's basically a union. It's represented by U. Yes, first letter of the word. So it's written as, so if you first take element from A, then, so what happens is you have a clone guy coming from this set, this set, this set. So if you did clone from this and this, and then you did a clone from this, it's basically A union B union C. Okay, that's D. So, but if you basically made a small little party with these guys first, you're like, oh no, let's do it in 2 steps. Let's call A, let's do A union B, and then once we have A union B, then let's have a union of A union B with C. So A union B is basically 1, 2. I'll just do this, okay? And then if you want to do A union B with C, then you're going to do it this way. That's again 1, 2, 3. So the brackets basically imply that first you had a union of A and B. Then you're unioning that with C, which is a bit different, which is because now you're going to basically take elements from A union B and put them in a box, and then from C and put them in a box. That's what you're going to do, which is different from taking from A. So A, B, C is different from taking from A union B and C. So in the second scenario, you're just taking from 2 rooms, which is this scenario. But in this scenario, you're taking from 3 rooms. So that's up to you. You can do it however you want. You can do B union C and then do from A and B union C. Or you can be like, oh no, I'm going to do A union C, and then I'll just do B union A union C. That is, you take from B and then you take from A union C. That's what you do. So these brackets are for that. So I want you guys to try out these brackets. I'll also give like a couple of example problems probably in the next lecture. So this is very, very simple stuff, but I'll give you example problems in the next lecture. Right now I want you guys to try out with the brackets and stuff like that. Take it in. Everything that's happening. So this is the union symbol. The next thing I'm going to teach is the intersection, which is going to happen in the next class. This is very, it's kind of short, but this is what the union is all about. And example problems, they'll come. After intersection, maybe I'll give a couple of example problems. Okay.